So we're going to use perms and coms here. Perms and coms. And don't forget your good old fundamental counting principle. It's still there. Okay, you can still use it. You don't have to follow these steps. These are not steps that perhaps are in a textbook or whatnot. These are just something that I developed over time. So this is what I would do. Determine if order matters. If yes is most likely permutations. If the answer is no, it's combinations. Order does matter for passwords, guys. Okay, always. When I was marking the test, some of you chose combinations, right? It's definitely permutations because order does matter. You typing in 2 first and then 5 versus 5 then 2, it's a totally different code, right? So always remember that. Determine the total possible arrangements given no restrictions. This is your sample space or your universal set. So for example, there are 10 of you in a team. How many times can you line up for the picture? That would just be 10 factorial. However, if I now ask, what if you and your friend want to be together? Now you're adding a restriction to it. And so that's not your universal. The universal is just everything, okay, without restrictions. I should say no restrictions. The third step that I would recommend is determine the total desired or favorable outcomes. This is based on conditions or restrictions given, okay? So you will be given some kind of, what's the probability that you and your friend will be together? What is that probability, right? So we're going to narrow it down. That's your NA. So your NU is everything. NA is like the event we're after. That would be an added restriction. And remember, guys, NU is always bigger than NA. Right? This is all possible outcomes. This is like after you putting some restrictions in there, this will be a smaller number. And I say this because sometimes students get a bigger number. You got to go back, right? Something is going wrong with your calculation. Last step is write your final answer as a fraction. Reduce is optional. You can write it as a fraction decimal percentage, but then you'll basically stack them. Watch this, right? The NU, that's going to be the big number that goes there. And then the NA is on there. So that's, you put the puzzle together basically. But I find them separately and then I stack them. Okay? So that's what we're going to do here. So it is chapter 4 all over again. Okay? To a certain degree, except for the stacking part here. So, page 15. There are 4 band and 6 dance students. 10 total. A teacher would like to select a team of 4 to represent Sisler at a convention. There's a team of 4. What do you think is going to happen here? Perms or coms? Combinations. Yes. Committees, teams, you name it. There are no specific positions mentioned. You just go team. What's the probability of having a team with exactly 3 dance students? Exactly 3 dance students. What does it say here? It doesn't say how many ways can you select exactly 3 dance, a team with 3 dance students, right? It doesn't say that. It says what's the probability. Okay. So I'm going to highlight that part. That is the probability. So it's almost asking you to do 2 things. Okay. So we're going to have to write it like this. NA over NU. We're going to have to account for both of those things. I don't care which one you do first, as long as you do them, right? So I'll say, what's the NU in this case? I'll just go arrow like this. We'll work it out. Well, no restrictions. I don't care what Like if there's all band students, all dance students, a mix, I don't care. That would be the restriction. That's your universal. How would you write that? 10, choose 4. That's it. Let's come up with that number. Alpha window. If I design one of these, I will make sure that that button is on our screen, right? On our keyboard. So 210 teams. Okay. And then, so now it's my NA. What's my NA? It's teams with exactly 3 dance students. You know, the exactly, sometimes they don't add that. Sometimes they just say teams with 3 dance students, but they mean exactly 3 dance students. They don't say at least, right? Like at least they will definitely put in there, or at most. So exactly it depends on whoever wrote the question. So here we go. We will say, well, if you need exactly 3 dance students, then I need to be careful. I need to go 6, choose 3, but I still need to make sure I have a team of 4, correct? So I will have to choose another 1 student from the 4 band students that remain. And always remember, total is 10. That's how you check if you're doing this right. Team of 4. Sorry, I know that's small. Let me zoom in a little bit. I can probably do a little better than that. Just remember that, right? Some of you don't need to write that down, okay? So then let's go and find 6, choose 3, times, I'm just going to copy paste that again. Oh, 4, choose 1 is 4. What am I doing, right? However, it might come in handy later to have this. So that's just 80. 80 teams. And now we're ready to state our final answer, finally, right? So probability of exactly 3 dance, almost like, you just say like this. My total possible teams that I can form would be 210. And 80 teams are what I'm looking for. That's the favorable outcomes. Those are the favorable outcomes. Okay? And then you're good. And trailing zeros, you can always cancel, right? So that's really 8 over 21. You divide both by 10, in a sense. That's what you're doing there. And that's it. That's it. Let's state that as a decimal. So as a decimal, this would be 0.38095. So that's a bit of a problem. So it's actually, it turns to this, which is 38.10% chance that will happen. Let me zoom out a bit. You can't see that, can you? So there's a quite high chance for that to happen, actually, right? It's not super low, like drawing one card, like a specific card from a deck of cards. So how is this different? It's having to do both pieces to come up with your probability. Okay. Let's try that one more time. What is the probability of having at least 1 band student? First of all, the probability is important. At least 1 band student. I know this is adding a lot to the mix here. It's Friday, right? We already know the total, right? The universal we already know. So we don't have to worry about that. So the NU is still 210. Okay, it hasn't changed. We're still talking about the same available number of students. So, hey, we just have to worry about the NA part. So let's do that part, the NA, the events we are after. How would you do that in this case? If it says at least one band student, indirect reasoning, does that ring a bell? We're going to go total minus no band students. That's how I'm going to find it. I should have given probably a bit more space there, but so total is 210 minus no band students. Then I have to go from the 4 band students, I'll select absolutely none of them. And from the 6 remaining dance students, I'm going to choose all 4 to make my teams. So I'm basically not, so for choose 0 is just 1. So this is 210 minus 6. I made a change on my original, that's why I have to retype this fun stuff here. 6 choose 4, 15. Okay, so 210 minus 15, that's 195. Oh, you caught it? It's Friday, right? It's not 15. This is 15. It's 4 times 15, so it's 60. Sorry, guys. Good catch. Okay, that's better. So that's 150. So this in my books would be half off if you show me all the work, because I see that you understand exactly what needs to happen, right? So that's 150. So probability of at least, you don't have to do this, by the way, on your test, at least one band. It's just for your notes here. It'd be 150 over 210. Cancel out. That's 15 over 21. 3 goes into both of them, right? 3 goes in there 5 times, goes in there 7 times. 5 divided by 7, 0.7143, and that's 71.43%. So I go commas because when you round, you're not exactly equal, right? You're rounding, so I go 5 over 7, comma, that, comma, a percentage. So that's even higher. That percentage is even higher. Okay, the next one, it's based on B. This one is based on B. Can you answer that? We just practiced that. Take 1 minute to answer that before I do it. This is something that is harder to wrap your head around, but that's okay. I still want you to be exposed to these questions, okay? Next, what are the odds of having at least one band student? So odds, you want what? The event is at least one band student. I don't even know how to at least one will go here, and at least one not will go here, if that makes sense. Right? So I'll use my simplified fraction, even though any of these will work. Any of them will work. So I will say, well, it's 5 to 7 minus 5. It's 5 to 2. Okay? So you can never just have the 7 here on its own. If you ever answer like that, it's like wrong right away. Okay? You can't have it. Always remember, these two numbers add up to what? The denominator in my fraction. Right? Okay, moving on. 16. John, Ethan, and Adriana are competing with 10 other runners in a cross-country competition. If all runners have an equal chance of winning, determine the probability of John, Ethan, and Adriana to win first, second, and third place in any order. But this first, second, and third place specific positions are mentioned. It's not just saying ending in the top three, specific positions. Perms, okay? Or I will say, I will also use or fundamental counting principle, right? But do not use combinations. You choose, okay? So remember, what is the word here is probability. So it's not just find out how many ways they can be first, second, and third. So this is what we're going to do. NU. I'm going to go arrow like this because I'm going to do a bunch of random work there, not necessarily equal to. No restrictions. I don't care about the three in this case. All I care about is finding out how many ways can those runners finish first, second, and third. So we'll do this. 1, 2, 3. First, second, third. And that would be what? How many are there in total? The 3 and with 10 others, right? So I will go at the top here and just say this whole thing is 13 total. So I'm going to just say 13, 12, 11, right? Or how can you write this using permutation notation? 13 pick 3. Same thing. Let's come up with an answer there. Let's we have that 17, 16 ways. Okay. And then NA is with restrictions, right? AKA the 3, right? The 3 finishing first, second, third, okay? I just care about those 3 individuals making it. So that'd be first, second, third. I have only 3, then 2, then 1 to choose from. Or 3 pick 3. And in this case, because you're using up, you have 3 elements and 3 spots, you could actually say 3 factorial as well. It's still okay. And that is what? 6 ways that those 3 could finish up front. Okay. So probability in this case would be 6 over 17, 16. That's 0.0035 or 0.35% chance that that will happen. So that's how this is different than the previous unit. We're now worrying about 2 things. Remember, I did it quite often. It's like no restrictions, and then you found another one with the restrictions. That's what we did, just number of ways, and now we're just stacking it. Okay. All right. I'll do this one here because this is a classic. Okay, classic. Put that down. A true and false or tossing coins, anything like that is what I consider classic. And I kind of talked about that in the direct indirect lesson. I gave you a tree diagram. So Fiona tossed, so maybe I should say true, false, works the same way, okay? Same way as tossing a coin. Determine the probability of the other 3 coins to have at least 3 tails, okay? Do I need to change that? Can we change that to at least 1 tail? It'll be more applicable here. At least 1 tail. So we have 5 coins. Watch this. 5 coins. The first 2 landed on tails. So technically, if you want to mix this up, there's a tail and a tail. So you only have one option. And I'm going to show you now. This is the third coin, sorry. It's heads or tails. Then it's your 4th coin, heads or tails. Heads or tails. And then this is the 5th one. Heads, tails. Heads, tails. Heads, tails. It's tails like that. So this is the visual tree diagram. Underneath it, I will show you that it's 1 times 1 times 2 times 2 again times 2, right? So there's 8 options. Every event, so this is the fundamental counting principle, and I mix it up with a tree diagram. And the reason I do tree diagrams is because we're going to use them quite often in this unit. Okay. So let's write out our outcomes. We could have all of them. By the way, guys, every single one has tail, tail first. So you can go ahead and go tail, tail, because that's what happened in the first 2 events. Okay. Okay, I have 8 here. And then now you just follow the rest of the tree. So this will be tail, tail, and then 3 heads. And then heads, heads, tails. And then it's heads, tails, heads. And then it's heads, tail, tail. And over here, I've got tail, heads, heads. I might have to zoom into this later, but just follow that. Tail, heads, tail. And then I've got tail, tail, heads. This is fun, isn't it? Not. Okay. Let me zoom into that. I basically just follow my tree diagram, right? As I'm doing that, I just follow that branch, the next branch, and so forth. I think you could answer this question already without me doing the actual indirect reasoning. But if you want at least one tail, at least 1 tail. Oh, that's why I had 3 tails there. It's Friday, right? I hope you didn't use a pen for this one. Can you actually erase this whole thing and just leave it at 3 tails, or else it doesn't work? That's when I have those brilliant ideas to make 5 coins and then 2 tails at first, right? Anyways, sorry about that. Back to where it was. At least 3 tails. So when you look at this, at least 3 would be 3 or more. So let's circle them. Does it have 3? This has 3. This has 4, but it's good. We're still counting that. This has 3. This has 4, but we're counting it. This one has 4, but we're counting it. And then this one has all tails, right? So it's still, this would be our NA. just 7 outcomes, and everything else is our NU, which is 8 possible outcomes. This is also our NU down here. We already determined that. Yeah, this probably didn't help with me changing that all up. But probability would be 7 over 8, which is 0.875, which is 87.5%. We'll just leave it at that for now. And here, I'm going to change it up a little bit. We're going to leave the bottom here. Time allowing, we'll come back to that. I want you to go to page 18. And there's a lot of space on page 18. I want you to use the bottom half here. The bottom half of page 18, that's what I want you to use. A code consists of 5 digits. No letters. I'm going to do no letters on this one. Just 5 digits. And that means 0 to 10, right? If I don't tell you otherwise. What's the probability of the code having no repeats? What's the probability of the code having no repeats, like no digits repeating? How would you do that? Probability, I need NU, NA. Okay. What's NU in this case? Would I care about the repeats? I wouldn't care about it. I'd be almost like ignoring. It's like, well, how many passwords are even possible, right? All possible codes without restriction. Without restrictions. I'm going to do that right next to it because I want to save space here. So we would have 1, 2, 3, 4, 5. That's just 10 times 10 times 10 times 10 times 10. That's 10 to the power of 5. Let's just leave it like that for now. 10 to the power of 5, we'll just leave it. We know it's 1 followed by 5 zeros, right? So we'll leave it. NA would be no repeats. So we go 1, 2, 3, 4, 5. So that'd be 10, 9, 8, 7, 6. Or how would you do that permutation notation? 10 pick 5, correct? I'll just leave it like that for now. I won't do I won't actually calculate that. I'll just do it at the very end. Okay. So here we go. Probability would be 10 pick 5 over 10 to the power of 5. And I just made this up, so I need to quickly calculate this before you catch up to me. So that'd be 30,240. And this would be, oh, I said that already. 5 zeros, right? And so this does make sense. If you it ends up being 189 over 625. I'll just leave it like that. We won't do decimal percent. That would be the probability of the code having no repeats. Okay. B, I have to phrase this carefully. Probability of code. Let's see how you're gonna look at me after this one. Probability of code having repeats, comma, but can't have 5 of the same. There's one question that asks something like this. I couldn't write the whole thing out the way I wanted, but what I mean is you can't just do 1, 1, 1, 1, 1. You can't do the same number for all 5 digits. You can't do that. Or 0, 0, 0. Like, you can't do that. What would you do there? Any brave volunteer? How would you do that? How many codes could you make that have all 5 the same digits? All of them 0, all of them 1, all of them 2, all of them 3. 10 codes. That would only apply to 10 codes, wouldn't it? In this case, because I have 0 to 10 as my option. If it had been 1 to 10, then it's right. Did I say 0 to 10? Never happened. It's 0 to 9. Can you change that? Because otherwise it's... But if it had said 1 to 9, it would be 9 options. 0 to 9 is 10 options, right? So probably having the same code would be like this. NU is still 10 to the power of 5, hasn't changed. NA would be, watch this, it'd be 10 to the power of 5 minus 10 codes. You want me to write them all out or no? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think this will do. I won't actually do it, but this is 1, 2, 3. You get the point, right? I will just go dot, 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 right? 10 codes. There are 10 codes that this applies to. Those are the only 2 options. So technically, NA is therefore 99,990. That right? These codes have repeats, but they do not have 5 of the same, right? So you're down to that. There's one question that does this in the textbook, so I thought it threw me off a little bit, but then after a while, I was like, oh yeah, so that's what they mean by that. So don't let that throw you off. So the probability would be 99,990 over 100,000. So I'm going to stop here. I really want you to try. I want you to highlight that, right? These questions, they are good. They are teams. It says 1 to 6 and 10. Let me just check, because I thought there were some good ones further down. 10 has committees. Yeah, that makes sense. One second. Yeah, 5 is gonna be interesting. Can you add 9 to this? because 9 is the password. This question that I just did is going to help you with 9. However, it still has more. It has more layers to it. Okay. So when you come back on Monday and you come to me, it's like, Mr. Jason, I don't get how to do this. I don't get how to do that one. I will actually be happy for a little bit just because you're like, oh, you tried it, right? You tried it, you sat down. And on Monday, I'm going to probably have to clarify some of these. Okay? Thank you, guys. Have a good weekend.